Force is a push or pull exerted on an object in order to change the motion of the object. Force has size and direction. Force is measured by multiplying the mass of the object that has a force exerted on it by the acceleration of the object. The units of force are newtons, and they are calculated by multiplying mass times acceleration. To break an egg standing upright, it takes about 29.5 newtons of force. To break an egg on its side, it takes about 37.7 newtons of force. The difference between balanced and unbalanced forces is that when a net force on an object is not 0 newtons, the forces on the object are unbalanced. An unbalanced force causes a change in the velocity of an object. Change in velocity may change speed, direction, or both. It can also cause a static object to start moving or a moving object to stop. Balanced forces will not cause a change in the motion of an object. Newton's first law relates to my egg relative to my protection system because Newton's first law states that an object at rest remains at rest and an object in motion remains in motion, unless an outside force acts on them. So, the egg was in motion when it was dropped, which was attached to my protection system, so they were both moving. The outside force that acted on the protection system was the ground, making the protection system stop. Since the egg was attached to my protection system, it also stopped moving because the protection system acted as the outside force that made it stop. My egg was traveling 0.75 meters per second when it hit the ground. I calculated this by dividing distance by time. The Earth pulls my protection system down with 0.9212 newtons of force. My protection system hit the ground with 0.006627 newtons of force, and I calculated this by using the equation 2 times mass times velocity divided by time, which is the equation for finding impact force. My egg hit the protection system with about 0.0033135 newtons of force, and I estimated this by using the impact force that I calculated for the protection system hitting the ground and divided that by 2, because I thought the impact force of the egg hitting the protection system would be about half the impact force of my protection system hitting the ground. Newton's second law states that the acceleration of an object depends on the mass of the object and the amount of force applied. This is related to my project because when we dropped the egg, it accelerated. The ground pulled it down with force, and the egg also had mass. According to Newton's second law, these things will determine the acceleration of the egg. Three action-reaction pairs that were involved in my project were the ground in my protection system, the protection system in my egg, and the eggshell and the inside of the egg. They are pairs because one of the objects in the pairs exerted a force on the other, and according to Newton's third law, this means the other object applied an equal and opposite force on the first. Our project hit the ground with 0.00705 units of momentum, and we calculated this by multiplying velocity by mass. The mass of our project was 0.094 grams, and the velocity was 0.75 meters per second. My egg will actually hit the material inside the two cups and possibly the cups themselves that are in my project. The egg will hit with 0.0075 units of momentum, and I calculated this by using the estimated force of the egg hitting my project and multiplied that by time because that's what the internet told me to do. Newton's third law states that whenever an object exerts a force on a second object, the second object exerts an equal and opposite force on the first. This is related to my project because the ground exerted a force on my project and my project exerted an equal and opposite force on the ground. My protection system is designed to absorb force through marshmallows, crumpled paper, and coffee filters inside a capsule made of 2 cups put together. We wrapped the capsule in paper to absorb force. Then we taped on an inflated plastic glove to the protection system we had created to slowly deflate and slow down the whole contraption. Air resistance affects the acceleration of a falling object on Earth because there is a set velocity that objects fall at, which is 9.8 meters per second. However, air resistance causes a drag that slows down the falling object, so there is a change in acceleration. The mass of an object relates to the gravitational force the object exerts on other objects because the bigger the mass of the object, the larger the gravitational force. The terminal velocity of our egg was approximately 0.666 meters per second. I calculated this by using the equation velocity equals the square root of 2 times the mass of the object times the acceleration due to gravity all over density of the air times projected area times drag coefficient.